Let's hit the ground running. So thanks everybody for joining. A few housekeeping rules before we joined. This is a webinar hosted by Amit and myself. I'm Ido. I run customer success for lakeFS. With me is Amit. Hi, Amit.
Hey, Ido.
We're here today to talk about specifically RBAC. As I mentioned, Amit and I both support this open source project called lakeFS that has an element of lakeFS Cloud in it that allows RBAC for data lakes. Before we start, I think it's going to be really helpful for us to be able to give you the right level of details into lakeFS and not lakeFS if we understand a little bit from you who here actually has used lakeFS before. It will be great to hear from you. You should have a meeting, you should have a question jumping in front of you right now. It will be great to hear from you if you heard of lakeFS before. Is this your first time running through lakeFS or not? Because then we can go about this differently and talk more about basic concept or talk about specific object. So let's talk about specifically RBAC on top of lakeFS. Seems like everybody here is somewhat, or most people here are somewhat familiar with lakeFS. So I'll continue down that route. Okay, fantastic. Thank you for sharing, guys. This will make, I think it will make it better. But having said that, if someone has questions that are more basic, please don't hesitate and ask, because we do have some newbies to lakeFS anyway here with us today. So thank you for answering. Last chance to answer. Okay, fantastic. So, okay, so we're all here obviously to talk about role-based access control on top of data lakes. So I think the benefits are actually are probably pretty obvious to the people that are on this call, because otherwise you wouldn't join today. But just to cover them generally, the way that we look at them in Treeverse and in lakeFS is that we would like to achieve role-based access control on top of a data lake because it's a requirement that requires high security. It has PII data. It might have intellectual data, intellectual property in it. It has business-specific data that's important for us. And even if it wasn't important for us personally to secure it, we're required to secure it because there's compliance regulations like HIPAA, like GDPR that require us to be able to control the access. And we want to do that in an efficient way. Role-based access control is an efficient way to manage access across huge organizations with a lot of data access for a lot of individuals in a way that's also accountable, i.e. we can prove that Amit and I never have access to the production PII data of our users because we just don't have the permissions to do that. And it's also a highly customizable way to do that. So if I'm a support engineer and I actually do need to get access to something for the sake of troubleshooting, which I'm legally allowed to access, then I should be able to at least for a certain amount of time get access to that data, and then my permissions will be revoked. So there's a lot of benefits of having a system like that on top of a data lake. But Amit, you've been doing this kind of work with big data for a while, from not to embarrass you, but for a while. You have lots of experience with big data. So what's the challenge? Why is this more difficult to do on top of data lakes than it is on top of, just a database?
Yeah, so I started from the database side. I was a database engineer or data engineer and DBA, and then I moved to the big data side. And on the big data side, it gets more challenging to manage the access control in the database. I was used to doing the RBAC, role-based access control, but it was for a small data set. But in the data lake, it's a larger data set, a lot more problem. Like you have to have a lot of policies implemented, a lot of different roles to manage different types of users, because you have millions and trillions of files, sometimes billions of files, which you have to access control in the data lake. So scalability and performance becomes very critical then, because you have to check all those policies in real time to allow the permission to a certain files. So scalability performance is a challenge, and it gets more challenging when you are trying to do the version control your data also. Like if you're using lakeFS to do the version control it, then you have different branches, different different versions you have to manage. And also if you are trying to reproduce, if let's say somebody accessed this information in the past and you want to reproduce and see what happened, what kind of changes happened, then it gets more and much more complex and more challenging.
Yeah, so it's not bad enough that it's difficult to begin with without anything, but once you get to the point that now someone needs to access the data that's 3 months old to troubleshoot something, then we need to make sure that they have the same permission to access the historical data as well. Or if I'm a data scientist that working on machine learning reproducibility of models, and then also I need to be able maybe to access not the production PI data, but silver data or whatever different people call it, and only that. So yeah, so those are the complexities that we're going to talk about, how lakeFS helps solve them today. Most of the people on this slide are familiar with lakeFS, but for the sake of the people that are not, I'm going to very quickly go over this. lakeFS sits on top of an object store, Google Storage, MinIO, Azure Blob, S3, and provides Git capabilities on top of an object store. It's meant to create versioning capabilities on top of data lakes. So the ecosystem of tools that our users are using, instead of accessing the object storage directly, which they still can, they will access through lakeFS and get those versioning capabilities. And then to make the refactor very easily, what we did is, if before we were accessing a collection and a bucket, now you will include a name of a branch or a commit identifier. So you will go and you look at production, test, development. Those are all branches. Or you can go and you can work against your bucket and look for a specific commit identifier, like production yesterday at 5 p.m. before an ETL ran, or production yesterday at 10 p.m. after an ETL completed. And the idea is that lakeFS manages all these versioning in a very transparent way that is very easy for data engineers, data scientists, or any data practitioner to work with on an ongoing basis, because you're already familiar with this S3 or Azure Blob or whatever object storage that you use way of work, and you just continue working against your object storage with another layer of abstraction that handles the versioning for you without the need to do anything. And then the Git actions themselves, like creating branches, committing, rolling back, merging, and so on, they can be done through an API, through a command line. This is a command line, for example, like CTL, or they can be done through Python code, for example. And in the context of role-based access control, whatever it is that we're going to speak about today will take impact on my current version and all my historical versions, all my branches, all my commits historically throughout lakeFS. And we're going to walk you through a demo that is a very simple demo, but we believe it does a good job in explaining role-based access control in lakeFS. Generally speaking, we chose a IAM-like approach. So similar to what you're familiar from different cloud providers, we have the notion of users, groups, and policies with many-to-many relationships between those. So many users can be a part of a group can have multiple policies associated to it, a policy can be attached to many groups, users can be parts of several groups, and so on and so forth. And then in the specific example that Amit is going to show us today, we have 3 groups: administrators, data scientists, and developers. And we're going to create one individual user for each of these groups: a developer, a data scientist, and an admin. Again, obviously, this can be a lot more complicated than this, but for the sake of the demo, we did something straightforward. And then we created 2 policies in place. One is block merges to main. What this policy means is that nobody can promote data, not code, data to production. And we attach this policy into the data scientist. So the data scientists, if they go and they work on their branch and they make changes and they want to promote it to production, they actually physically can't do that, and they can't break anything in production because they don't have permissions to do that. The other policy that we created is block access to PII data. This restricts access to a specific directory. This also already shows, and we're going to show this soon, that the granularity here is very big, and you can do this for a specific subdirectory of a repository or a branch, right? So in this case, all the PII directories, anywhere they are, developers cannot access them. There is a third element here, which is a lakeFS element, not necessarily or fourth actually, not necessarily an IAM-like thing, which is the configuration of the production branch in lakeFS, which will be a protected branch. What that means is that nobody can write directly to prod. This is a common notion with lakeFS users, which is we have the production branch, and then any type of ingestion, any type of transformation will be done in a separate branch. And then we will regularly promote data either from the ingestion branch or from the transformation branch into production. By making it impossible to write to prod and impossible to promote to prod, that's what guarantees 100% that a user that is in this group, for example, will not be able to write data into prod. I spoke for a while, so I'll pause a little bit. This is pretty straightforward, so I'm not sure if there's any questions so far, but if there are, please don't hesitate. I'll pause for a second and wait to see if someone has a question in the chat. No, so far so good.
Yeah.
So Amit, what are we going to see in the demo?
Yeah, let me share my screen. Meanwhile, if you can, I don't have access to the poll. If you can ask that question regarding the object store, that will be helpful. Thank you.
Yes.
Okay, so yeah, before I start, I just like to know what kind of object store you are currently using. Accordingly, I'll focus my demo. For the demo, I'm going to use S3, but I'll also talk about it. lakeFS Cloud works. lakeFS Cloud works for Azure Blob Storage or Google also. Okay, so while people are answering that poll, let me just start here quickly. So I'm going to set up a demo environment. So I'll walk through this demo from beginning till the end, like how to set up this environment and how to run this demo. So the requirement for the demo is to have lakeFS server, and role-based access control functionality is available in lakeFS Cloud only. It's not available in open source version. So for that, need to register for lakeFS Cloud. So that's what I'm going to do just to show you here. So basically, you can go and register for lakeFS Cloud, and in a few seconds, you will have your cloud environment up and running. I already have my cloud environment running. So let me log into that. So once you register and log in, you'll get kind of this kind of view where by default, you will get one instance up and running. We'll provide you lakeFS server up and running in a few seconds once you register, and we'll also provide the storage bucket also along with that. Or if you want, you can connect to your storage, or you can spin up another lakeFS Cloud instance in any of the region of your choice. So you can just go and enable that. So I already have this up and running, this cloud environment. So let me click on that to go to my cloud instance. Okay, so I'm already logged in here. So if you sign up, it will provide you a sample repository. And we also provide an object store along with that. So this in this case, I have using S3 or AWS environment. So I have this S3 bucket assigned to me. But as I mentioned earlier, you can connect to your storage or bucket also, whatever storage object store you use. Okay, so that's the first requirement for the demo. The next one is to use our sample, and we provide our sample repository. Let me go there. And in this sample repository, we have multiple samples, including this RBAC demo, which I'm going to run today, and lots of other samples are there. And also instruction how to run this sample repository or sample demo. So you have to, it requires cloning the repository. So you will need Git, as well as running this sample demo environment in a container. So you will need a Docker. So those are two prerequisites for this. So let's start this. So I already cloned this samples repository on my laptop. So I already have done this cloning. It will take few seconds to clone it. And then go to this folder here. And I will run this demo repository demo in a container. So let's just copy this command to run this, build the container and run the container. Currently, I don't have any running container yet. So if I go into my terminal and build and run the container, it took me a few seconds, but in your case, first time when you run, it will take time to download all the images required for this container. So it might take 5-10 minutes to download those and build those containers. So now I have my container running. So this will be my demo container. Once the container is running, then you click on open the Jupyter Lab UI. So just click on this URL here, and it will straight away take you to the Jupyter Notebook environment. And as I mentioned earlier, this container has all the requirements, anything you need to run this demo, and it has multiple samples here. So today I'm going to just focus on RBAC functionality. And as Ido mentioned here, that's the step I'm going to do. I'm going to create these three users, going to create these groups, and also create these policies. And so it has a lot of steps here required to just set up everything, but I'm not going to go through each step, but I'll quickly walk through those. So first thing you need is to connect to your lakeFS server environment, which is this cloud environment. So you need to have access key and secret key. To create the access key and secret key, you can go to admin and just create your access key from here. I already created my access key, so let me just copy and paste. And also you need the lakeFS cloud endpoint URL, which is this URL over here. So let me I have already saved this here. So let me just copy my credentials and paste this in my notebook. And then specify the variable for repository name. You can leave this as is, or you can change the repository name if you want, and also provide the storage namespace where you are going to create this repository or object store where this repository will be stored. So as I mentioned earlier, in this case, I'm using S3, but this will work with blob storage or GCS also, Google Cloud Storage. So
there's an interesting thing to call out here for everybody. For those of you who have not spun lakeFS Cloud, or maybe even have not spun lakeFS Cloud recently, because this is the recent change, today we actually spin up lakeFS Cloud on our buckets, because we find that that's a really fast way. You don't have to wait for any permissions for your buckets. Everything is done on our storage, and you can work really, really quickly. So the namespace that Amit is going to show in the repository, every namespace for every repo in lakeFS has to be unique. So we'll take the storage namespace that you'll see comes out of the box in your repo, and then we'll add it here. having said all that, and I could not stress this more, the way that you will obviously use lakeFS in real life, as my 8-year-old calls it, is against your buckets, right? And you can also connect lakeFS Cloud obviously to your buckets, and if you do that, the data stays in place within your buckets, and lakeFS needs very, very minimal permissions just to know which file sits where for the sake of the versioning control. So the end game is, of course, not to use our storage. You will use your storage, but just to enable you a quick start. This is the way that you can work with the lakeFS playground on the cloud.
Good. Yep. And in this storage bucket that we provide, you can just add an additional subfolders. So if you are to create multiple repos, you can add multiple subfolders here. So I'm just going to use this storage namespace for today. And then there's some additional variables for versioning information. You don't have to change anything. Then using that access key that I assigned here in the variable access key in the endpoint, I'm going to create a Python client API for lakeFS Python client API. So these are the access key endpoint using here. For this demo, you only need is the Python, and it's running in the Jupyter environment, notebook environment. So those are the only two requirements from the programming side. Then I'm going to create the admin1 user. I'll just quickly walk through all this. I'm not going to run each step one by one, but I'll run all that together and then assign that admin to an admin group, and also create the access key. You can create the access key using the UI, as I mentioned earlier. You can do all these things like creating the users, groups, and permissions, policies, everything you can do through the UI. I'll come back to this, but you can do this programmatically also. So just I'm creating the credentials for that admin, creating the client for admin here, Python client for admin to connect to lakeFS. And just
so that gives me the ability in the code later to go and use and pretend to be the admin, pretend to be the user when I run the Python code to the different clients.
Correct. Yes. So that's where I'm creating the admin1 client, which I'll use it further later on to verify things. And then I'm creating a developer1 user, and which will be assigned to developers. So when you sign up initially or to lakeFS Cloud, we have predefined groups, couple of predefined groups, like these 4 groups are predefined: admin, developers, super users, and viewers. But you can either use these or you can create your own groups based on your requirement. And also we have these predefined policies, but in this demo, I'm going to create few additional policies, and I'll come back and show you how these policies look. So this developer goes into developer1 goes into developers group, and also create a credentials for developer and create the Python client for developer here, which I'll be using further in the demo. The next one is now the admin is also going to create the data scientist group. Data scientist group is not there by default. So that's where I'm going to create the data scientist group. And then assign certain permissions for data scientist groups, certain required permissions, like whether they can read, write, they can manage their own credentials, and they can manage the repositories. So assign those permissions, then create the data scientist 1 user and assign to data scientist group, and so on. So next thing is creating these policies. So the first one I'm going to create is, as Ido mentioned earlier, like data scientists cannot merge any data into production. This is just an example. So here, when I'm trying to commit into my main branch, my main branch is my production branch, then deny that for that policy. And if you can see, this is similar to IAM kind of permissions you're familiar with the object store. So here, for all my repositories for my main branch, if anybody tries to commit, then deny this for this policy. Another policy, and assign this to data scientist group. Yeah, go
And
ahead.
this is assuming that main is prod, right? Main will be prod in your repositories.
Correct. And the next one is more granular, where do not allow access to the PII information. If you're storing your PII information in certain folders or certain location, you can specify here in this case, for my current repository, for any object, if anything inside a PII folder, all the files, deny access and deny that actions called read, file system read or write, or any actions they want to do in file system. And these actions are defined in our documentation. I won't spend too much time on that. You can find that in documentation. And then assign this policy to developers. So developers cannot promote, they cannot access any PII data when they create the branches from the production data set. So I'm going to run all these commands all together. Let me run this instead of running one by one, just run all the commands so far. And now it is done. So if I go back to UI, so you can see if I refresh, now I have my data scientist group, the new one I created. I have these 3 users created. And also I have policies, these 2 new policies created. So let's look into quickly on this PII. You can look into JSON view, which you saw earlier. Again, it's similar to IAM policies that you are familiar with in object stores. Let's go back here. Now, so far was just the setup, creating all those users, group permissions. Now let's verify, make sure everything works fine. All the policies are working. So I'm going to just, for this, I'm going to create a repository, a new repository here. So let's go here. I got this new repository. Right now, everything is blank here. And now I'm also going to protect the main branch of this repository, so nobody can write directly to the main branch or the production branch, but you can merge through a different branch. You can run in the separate parallel environment, or you can do the parallel ingestion, parallel transformation. Once you have verified everything is done, then you can merge into the main production branch, but you cannot directly write to the main branch. And you can do that from the UI also. If you want to protect any of your branches, you can specify here. I just defined to protect my main branch or production branch. Now, if I try to directly upload any file, I'm trying to upload a file directly to the main branch in this case. So it doesn't allow, because the main branch is protected. I cannot directly write to my main branch. But if I create a separate ingestion branch, and I can upload my data files or the PII information to a separate ingestion branch and commit my changes, and then merge into my production branch. So that is allowed. I cannot directly write to the main, but I can have a separate branch and then merge into my main branch. So now I have my PII information here. And now let's verify that PII policy that developers cannot read from the PII information. Let's verify that. So first I'm going to connect as an admin, use the admin client, which I created earlier in this demo. So admin can access the PII information, and data scientists can also access the PII information, but developers don't have permissions to access that PII, any file inside a PII folder, just to make sure that all the policies are working. And then also I want to check whether a data scientist can promote write to the production data, write to production branch. So let's say if the data scientist creates a new branch, they are running some models, they are massaging some data, and then commit some changes. And now if they try to merge into production, they are not allowed to do that. So I think I went over time, so I'll just wrap up quickly here. Basically, this was just to verify all the policies are working fine. Thank you. Back to you, Ido.
Okay, fantastic. Thanks, Amit. That was quick. But I'll share a link here in a second to kind of see again for the webinars and so on. So you guys will be able to. That's why we have it as a notebook, right? So this way everybody can use it and reuse it in their own environment. Just a few other links that I think might be useful for you and explanations. So just to make sure we cover everything with those of you that might be newer to lakeFS and the line here. lakeFS is open source, so you can use it for free. The RBAC functionality specifically, just to make sure we don't mislead anybody on this call, similar to the single sign-on functionality, is an enterprise feature of lakeFS that's available either on-premise through the enterprise solution of lakeFS or through lakeFS Cloud, which is our hosted solution. So there's different ways to kind of consume this functionality if role-based access control is important for your business. Generally speaking, again, what's next? And we'll follow up in an email with everybody that attended today. Thank you. You can spin up a lakeFS Cloud easily in your environment, and that will come up again with our buckets. But then if you want to switch to your data and connect to your buckets, you can do that as well. And it will walk you through, including the minimal permissions needed and so on. This sample repository is available for you, and you can download that. And we also have, ending with number one, we also have a very, I think, effective and communicative community on the Slack where you can join, especially the lakeFS for beginners and help, our channels that are very helpful if someone has a question or needs help. I will open the floor for last questions. Before I do that, we'll be interested to see if this was helpful for you. So it will be great if you can take this a second to just answer that poll, just to see if this was worth your time. This helps us kind of understand what type of content we want to present in the future. Just wait 15 more seconds or so and let everybody answer. So I'll do that. So with that, let's see if there's any other last questions. Going once, going twice. Okay. Amit, thank you so much. Everybody that participated, thank you so much. Appreciate the attention. We will send the recording and the links. Again, everybody have a wonderful day.
Thank you, guys. Thank you, everyone.
Thank you. Bye-bye.